Alright, this is some practice problems in section 2.2. Let's look first of all at 1 through 8, and one of the things that they're asking you to do is to determine whether the numbers are prime or composite numbers. Well, you can look at the number 50 and know that that's a composite number because it's even, so you know 2 goes into it. But if you look at the number 13, nothing goes into 13 except 1 and 13 itself, so therefore it's a prime number. But what about when you get to numbers like 219? What do you do with that one? Well, you can get your calculator out and try a whole gob of numbers in order to do it. Or one of the ways that you can quickly find out as far as whether 3 goes into it evenly is to take the digits 2, 1, and 9 and add them together. And 2 plus 1 is 3 plus 9 is 12. Now, if 3 goes into this number, then 3 will go into that number. So even though 219 looks like it's a prime number, because 2 plus 1 plus 9 equals 12, and 3 goes into 12, 3 goes into 219. So let's look at that. 3 goes into 21 7 times. 21, bring down the 9, 3. So 3 goes into 219 73 times. So even that's kind of a weird number, 73 and 3. It is not a prime number like it would appear to. So that's just one trick to find out if 3 goes into it. Even numbers, you can kind of dink around with that and try to find out. Probably the trickiest one is 7. That's usually what I do. Like if I look at 219 and let's say it was 217, and it's like, well, I know 3 doesn't go into it, and I know most of the other numbers don't go into it. The only other option would probably be 7. So that's usually where I start. If it looks like it's a prime number, I will look and see if 7 goes into it first, and then kind of go from there. Numbers 17 through 48 are ones that we already did. Reduce each fraction to lowest terms. Let's look at number 48 real quick. Alright, so we'll take 273, and that could be a prime number, but let's add the digits up. Let's add 2 plus 7 plus 3, and that gives me 12. So because 2 plus 7 plus 3 is 12, then 3 goes into 12, then 3 has to go into 273. So 3 goes into 273, and this is where a calculator comes in handy, but I know it will work 91 times. Now, I'm going to circle my 3 because I know it's prime. And boy, 91 sure does look like a prime number. I mean, holy cow, 9 plus 1 is 10, and 3 doesn't go into 10. And, sheesh, it's not an even number. It just looks like it'd be a prime number. And this is, remember earlier I said, if you really think it's a prime number, try 7, just to make sure. So 91 divided by 7 is 13. So it isn't a prime number. So 7 times 13 is 91. Now those are both prime numbers, so that is as small as we can go there. Alright, now let's try the 385. Well, 385 ends in a 5, so I know 5 goes into it. And 5 goes into it 77 times. And 5 is prime. 77, I know whenever you have a double digit that are the same, like 55, 66, 77, 88, you know 11 goes into it. So 11 goes into it 7 times, and 11 and 7 are both prime. So 5 times 7 times 11. Okay, so we can cancel that 7 and that 7 there. And that gives me for an answer 39 over 55. So this is the reduced of 273 over 385. And that's it for 2.2 problem set, just to kind of give you a foot up on getting started with the homework.